working? Yes. Okay, I'm gonna talk to you about regular expressions, class ones in particular, and I'm sure all the computer scientists in the room are thinking, well, that's just tautology. We'll get to that. So a regular expression it's kind of a textual notation for describing a pattern of text. We use them a lot in computing to validate user input and to search for certain kinds of data within large data sets. That's not really very descriptive. Let's have a look at an example. So at the top here we have a regular expression, and at the bottom we have the text that it matches against. Letters will just match against letters, and then the circumflex matches against the start of a string, and the dollar matches against the end of a string. And with real hats it looks like this. But we can do more interesting things like that than that. So if we use the pipe operator, we can do an OR operation. So this will match against both a bat and a cat. Hopefully that makes sense to everyone. And we can do more interesting things than that. We can match varying numbers of things as well. So with the asterisk operator, it will match against any number of what's immediately before it. So this will match a fish. It will also match a fish with 3 eyes and a fish with no eyes. Okay, that's all about regular expressions you need to know for this talk. The syntax is a lot more complex, but that's all you need. Now here's the cool thing. They're just finite state machines. Hopefully at least some of you are familiar with finite state machines. Let's have a look at how this works. So here's the simple example. We have a starting state and an end state. We have this function between them. So you start at the state on the left. You take an input of E, that transitions you to the second state on the right. Nice and simple. Let's do the next one. Start at the state on the left. Now you can take an input of B or C to get to the next state, and then you have to take an input of A and then an input of T to get to the end state. Everyone still on board? Yes. Yeah? Okay, good. This, hopefully, not too much explanation needed. The asterisk operator is just a state that loops back on itself, and you can go around that loop as many times as you want, or you can skip it entirely. Okay. This works both ways. You can start at a finite state machine and turn it back into a regular expression. So how do we do that? Let's look at this one. The way we do this is we want to collapse it by getting rid of kind of meaningless constructs and turning them into equivalent constructs. So let's look at this state in particular. It's only got one pathway in, and it's only got one pathway out. So we can collapse it. So now we've got a single pathway from that earlier state to the end state. Now let's look at these two branches. They both start from the same state, and they both end at the same state. So we can collapse that into an OR operation. And then, as before, the state in the middle, we can just collapse that. And now we've got our complete regular expression. Now let's have some fun. So here's a simple game I've devised. You are the player in the top left. You can move up, down, left and right, and your aim is to get the blue circle in the bottom right. Here's the state diagram for that. I've allowed you to walk into walls and not go anywhere, and it's already a little bit messy. But we can compress that now into a regular expression, which, nice and simple. It's already 45 digits long. It's fine. Your computer can handle that, I promise you. Most programming languages, incidentally, actually have native support for these, so I could just punch that into pretty much any language and say, does this match against some series of inputs? And it'll tell me if it can solve that game or not. Here's a graph I nicked from Colin. I can't explain why it works or how it works, but if you start at any of the circles on there and wander around until you get back where you started, you will end up with site swap notation for a 3-ball juggling trick with certain constraints. There's the regular expression for it. It's a little bit messy, but anything that matches against that expression will be a valid 3-ball juggling trick. Yeah, that was a nightmare to put that one together. Who's familiar with Soccerman? Little game where you've got these pink boxes and you're trying to get them onto the pink dots. You're the player moving around and pushing them. So that's a fairly simple level. That's in 2-point font, and you'll notice it's falling off the bottom of the slide. But there's more we could do with this as well. Anything you can express in a finite state machine, you could theoretically turn into a regular expression. Take the Rubik's Cube, for example. It's technically got a finite number of states and finite transition functions between them. It might take you a while to calculate, but for any given starting point, you could make a regex that matches a solution. This is the talk that I got this from. Someone proposing that you could solve Pokemon Blue like this. I think it's a little bit computationally infeasible, but there we go. That's all I got. Thank you.